Welcome. If you're passionate about power systems, substations, transmission lines, and everything that drives the world of electricity, you're in the right place. Here, we break down complex electrical engineering concepts into simple, practical, and engaging explanations. Whether you're a student, professional, or just curious about how electricity powers our world, these videos will help you learn and stay updated. So stay connected with the world of electrical engineering. I am going to discuss the attraction armature type electromechanical relay. This is the simplest form of electrical relay. Nowadays, this type of relay has become almost obsolete, but in many running systems, these relays are still installed and in use. If we understand the basic construction of this relay, we can easily understand its working principle. This is a magnetic coil. These are the two terminals of the coil through which current is injected. As the current increases, the magnetic attraction of the coil also increases, and it pulls the iron plunger more strongly. As a result, the iron plunger rotates in this way. Now, see, these are the fixed contacts. The upper two and lower two are fixed contacts, while the middle one is the movable contact. At this moment, the movable contact is touching the lower contact, which means this part is a normally closed contact. There is a gap between the upper fixed contact and the movable contact. So this part behaves as a normally open contact. If we go back to the terminals, between these terminals there will be one normally open contact. And between those terminals, there will be another normally open contact. If we consider these as power terminals, then between one terminal and another, there is a normally closed contact. And again, between another pair, there is also a normally closed contact. When the relay operates, meaning the plunger is attracted by the coil, it rotates about the hinge. This upward movement pushes the movable contact upward, causing it to touch the upper fixed contact and close the normally open contact. At the same time, the previously closed contact opens. When the current is removed, the coil no longer attracts the plunger. Due to spring force and gravity, the plunger returns to its normal position. This movement reopens the contact that was closed and recloses the one that was open, thus restoring the relay to its original state. The entire system is normally enclosed in a semi-transparent or transparent plastic cover. Hope you got the idea. Thank you. Thanks for watching. We hope this video helped you understand electrical engineering concepts better. If you enjoyed the content, don't forget to like, share, and leave your thoughts in the comments. Stay with us and stay updated with more videos on transmission lines, substations, and power systems. Until next time, stay curious, keep learning, and keep the power flowing.